Hello everyone, and welcome to a new edition of H.E.L Explains with your host, Dr. Mario Torres Rodrigo. And today we're going to be talking about all things battery testing, different techniques, what the difference between them are, and when to use these types of techniques. So we know that when a battery is operating, when it's charging and discharging, there is going to be a heat exchange between the actual battery and the surroundings. So different techniques are going to be able to capture this heat exchange and is going to give us different information. So without any further ado, let's jump into the three types of battery testing that we're going to be discussing today and what makes them special. So let's jump in and discuss the first type of testing, isothermal calorimetry. In this type of testing, we're going to be holding our battery at a certain temperature. The aim is going to understand how charging and discharging processes are going to be happening. Are they going to be faster? Are they going to be slower? But also, we're going to be evaluating the lifespan of the cell at those temperatures. Are they going to be extended? Are they going to be shortened because maybe the conditions are not ideal? So the aim of this type of testing is defining what are the safe conditions for the battery to operate and what are the consequences of deviating from these ideal conditions. But we know for a fact that our batteries are not going to be always be working at ideal conditions. There's going to be conditions in which the temperature is going to be too high or too low, or there's going to be other environmental characteristics that are going to affect our batteries. So this is where environmental chambers come to. Apart from controlling temperature, we can control other parameters such as the humidity, the relative humidity of the air around the battery. That is also going to have an impact in how our cell works. But also, because of the design of these environmental chambers, they are actually prepared for the battery to go into failure. So there are certain regulations. UCA, for example, is designed to define what are the acceptable consequences of a battery failing in order to be considered safe. So for example, in this case, up to 50% of the electrolyte mass of the cell can just be lost, but it cannot disintegrate and it cannot be set on fire. But if we want to understand how a battery fails and what the consequences of this failure are, we need to go to the last type of testing, adiabatic testing. In this case, what we're going to have is that the battery is insulated and there's not going to be heat loss to the surroundings, which is going to allow us to get very in-depth information about the thermal runaway and the thermal events that happen in the battery failure. So some of the information we are going to get from this type of testing is the temperature at which this exotherm, this thermal runaway, is going to start, how much heat is generated by the thermal event, and finally how much the temperature has risen. Understanding this is fundamental because it's going to indicate us what the dangerous zones are and in what kind of mitigation strategies we need to set up in order to avoid reaching this dangerous zone. So we've seen in this video different types of testing and what the applications of this testing are. So that is all from me. My name is Dr. Mario Torres Rodrigo and I'm the applications leader at H.E.L. If you have any questions, if you have any comments, please reach out to us. Thank you very much.